Here we go with Unit 4.04. We're going to continue working with our unit circle in order to explain how to find trigonometric values for radian measures between 0 and 2 pi. So let's go ahead and take a look. We went over the method by which we're going to be able to figure out the sign, or the points that lie on the circle. And of course what we found is that for any point on the unit circle, we defined that point as the cosine of theta being the x value and the sine of theta being the y value. So that's for any point on the unit circle. And so what we did, if you remember, our method was to construct a right triangle using that ray, the terminal ray. So if I rotated, this is pi over 6 radians. I know that this is pi over 6, or 30 degrees. I know that this is 60 degrees. And so then I can use what I know about 30, 60, 90 right triangles to determine that the point, this point here, is root 3 over 2. That's the cosine of theta, and the sine of theta is 1/2. Okay, right, and the way I did that is what I'm looking at is that the y value is going to be the length of this side of the triangle. So I use the simple fact that when I have a 30, 60, 90 triangle, and if the hypotenuse is 1, then I know that the side opposite the 30-degree angle is going to be half of the hypotenuse, and the side opposite the 60-degree angle is going to be root 3 times the smallest side, so root 3 over 2. Okay? And so we went on and we did this for each of the points using angles that were very familiar to us. So if I rotate 45 degrees, or pi over 4 radians, well, then I can construct a 45-45 right triangle. And that will give me a cosine of square root of 2 over 2 and a sine of square root of 2 over 2. And I continue doing this for the next point. So remember, I know that I can work with either a 45-45 90 right triangle or a 60-30 90. And so if I rotate 60 degrees now, or pi over 3 radians, then I can also construct a 60-30 90 triangle. And so here, this point, it's going to be the opposite of this 30, 60, 90 right triangle, right? Because now the longest side is going to be the sine, the y value, and the shorter side here, the shorter side is going to be the cosine. So the cosine of pi over 3 is 1/2, and the sine of pi over 3 is the square root of 3 over 2. Okay, so now let's go ahead and take a look at this point here. Okay, and this is a rotation of 90 degrees, and so using the fact that 1 degree is pi over 180 radians, I can compute that this is going to be pi over 2 radians. But I can't construct a right triangle here, right? This, if I drop the parallel down, notice I just get a straight line. But remember, we're working on a unit circle here. So if we think about this being an xy coordinate, this is just the point 0, 1. So the cosine of pi over 2 is just going to be 0, and the sine of pi over 2 is just going to be 1. Excellent. So at this point, we have filled out an entire quadrant of our unit circle, right? And we've thought about finding points that lie on the unit circle in this quadrant. Okay? So now what I want you to do is pause the video and try and find the value of sine and cosine at all of these points along the unit circle. Okay? Do your best, make sure you use pencil so that you can erase, and we'll come out and we'll talk about the method, but I want you to sort of think it through yourself, and then we will talk. Alright, so I hope that went well. What you want to realize is that the circle is symmetric, right? So if I just take this quadrant here and I reflect it over the y-axis, I'm going to end up with this quadrant here. And so we can think about the analogous points, right? What would be mapped to what? This point here would map to this point. This point here would map to this point, and this point here would map to this point. And so now we just want to think about, okay, what are these angles here? So notice that this point over here is going to be in the same place relative to 0, 1. Well, we knew that this here is pi over 3 radians, which is 60 degrees, and then this is pi over 2 radians, which is 90 degrees. So this is a 30-degree turn. So this is a 30-degree turn as well. So from here to here, I've gone 60 degrees, or pi over 3 radians. And so this is going to be 2 pi over 3 radians. And that point is going to be, well, think about it. It's the same distance above the y-axis here, right? So it's still going to be, the sine is still going to be root 3 over 2. The only difference is instead of being positive 1/2 in the x-axis, the x value, the x-coordinate, the cosine of 2 pi over 3 is going to be negative 1/2. So the cosine is negative 1/2, and the sine of 2 pi over 3 is still root 3 over 2. And I can go ahead and I can do this with all the other points. All right, so over here, I now know that the cosine of theta is negative square root of 2 over 2. And the sine of theta is still square root of 2 over 2. And what is this angle here? Well, let's think about it. Here we were at pi over 4, right? So this was 45 degrees. Okay, so let's think about it. We then would go another pi over 4 to get to 90. And then we would go another pi over 4 to get to this angle right here. So if you think about it, I went 45, 90, 135. So this is going to be 135 degrees, and that's going to be 3 pi over 4. Okay? And we can do the same with this angle here, right? So I've turned this, it's analogous to this one here. I've turned 1 pi over 6, 30 degrees. Another pi over 6, so 2 pi over 6, another 30 degrees. 3 pi over 6, another 30 degrees. 4 pi over 6, another 30 degrees. And finally, 5 pi over 6, which is going to be this angle here. And what is this degree measure? Well, think about it. 30, 60, 90, 120, 150. Okay? And here, again, I just have a negative cosine value. So cosine is going to be negative square root of 3 over 2. And sine is going to be positive 1/2. Okay. So now that you've gotten the hang of it, I guess let's talk about one more. This point here, pretty simple, right? It's analogous to this point here, except that, of course, the cosine is now negative, so it's going to be negative 1, 0. Okay. So go ahead and pause the video, complete it on your own, think it through, count out the pi over whatevers, pi over 6, pi over 4, pi over 3's, to figure out the actual radian measure. I'm going to give you a few seconds, and then I'll fill it out completely, and then we'll move on to some questions. Alright, so there you go. We've completely filled it out. Go over it, make sure that your answers are correct. You're going to want to keep this, obviously, for your reference. And write down any, so if you don't understand why a certain point is the way it is, try and figure it out yourself. If not, write a little question in so that we can discuss. Last thing I want to talk about is I've written all of these in radians, okay? And I want us to start getting used to radian measures. But it is also helpful to know the degree measures because we'll want to convert back and forth. So what I'd like you to do is go ahead and actually try and fill them in. So we know this is 30, 45, 60, 90, and from that you can figure out all the rest. So 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and of course a full 360. So this is actually a 0 or 360 degree turn, right? I've already returned. So this would be 2 pi slash 0. So this is actually a good talking point. We'll term this, although a full rotation would be 2 pi radians, right? But it is also the same value as 0 radians. All right, I have a few problems for you to try, and I will see you on Monday. Here you go. Go ahead. Make sure that you are answering these to the best of your ability. I'm expecting to see that you have given it effort, that you've shown some work, that you've tried, and if not, you are asking, if you haven't gotten it completely correct, that you have some questions about what things mean or what you need to do.